എന്തെങ്കിലും ക്ലാസ്സിൽ കുഴപ്പമുണ്ടെങ്കിലോ ഒന്ന് എനിക്ക് വാട്സപ്പ് ചെയ്യുക കേട്ടോ, അത് കോൾ ചെയ്യുക. ശരി. So please write down a problem. Before the problem, just you want to write down a simple. For the last class, I think last 2 sessions before we had written some features of shape factors, right? Features of shape factor, that is, one thing is a1 f12 equal to a2 f21. Any problem, a1 f12 means a2 f2. That is, we're taking two shields, two systems, or two bodies. When heat is transferred from one body to another as a radiation, here f12 is the 1 to 2, and it is same as a2 f21. Okay, and thereafter we have said that if two surfaces are parallel and large, area equal to a1 equal to a2, same area, same diameter of same area we have taken. Therefore f12 equal to f21 equal to 1. Thereafter we want to write a particular two features, very important features also. That is, first one is a summation rule. And summation rule, that is, so for any problem there is, if we are taking two bodies, 1 2 3 is 1 2 3 anything, so we can write for this particular figure or particular theory as f11 plus f12 plus f13 equal to 1 if there are three bodies. If there are bodies, f11 plus f12 plus f13 equal to 1. Andana theory. That means if we are taking three bodies, 1 2 3, f11 means it is a1, like a1 a2 a3. f12, what is f12? f12 is the shape factor from radiation from one body 1 to body 2. Body 1 to body 2 is f12. Body 1 to body 3 is f13. And if it is a radiation from body 2 to 3, it is f23, right? From where to where? That's f12, f23, etc. So what is f11? f11 means radiation or a shape factor when a radiation is happening from a body to that body itself. From a body to that body itself is termed as f11. Where it occurs in the case of concave section, right? In the case of concave section, if a body is in type of a concave section, when a radiation is emitting from the particular body of a concave section, the radiation here from this point, radiation radiate rays like this. Okay, from this point, radiation may happens like this. One will go out and one will radiate to that body itself. In the case of concave shape bodies only. Okay, if it is a convex shape of the particular body emits radiation from one body to another only. It is not happening from that body to that body itself. So we can say that from f11 means that body to that body, f11 plus f12 plus f13. If the fourth body is f14 equal to 0, equal to 1. It is summation rule. നമുക്ക് ഇങ്ങനെ എഴുതാൻ പാടില്ല. എങ്ങനെ എഴുതാൻ പാടില്ല? f11 plus f21 plus f31 is equal. It is not correct. ഇതാണ് ശരി. f11 plus f12 plus f13 plus f1 from 1 to that body plus from 1 to second body plus from 1 to third body equal to 1. Okay, this is a very important equation. It is called summation rule. Summation rule in the case of radiation. Summation rule in the case of radiation. And again, we can say that for a plane body, the next feature is for a plane body or a convex body, f11 equal to f22 equal to 0. f11 equal to f22 or f33 equal to 0. Anything. Body like f11, that means that there is no radiation occurring from that body to that body itself. Take a particular cylinder as an example. Cylinder as an example. Cylinder, the two end side on a flat circular surface. There is a flat circular surface in the both sides. So there is no, it is taken as a body 1, it is taken as body 2, there is a body 3. There is no radiation happening from that body itself for the three cases, 1 or 2 or 3. 3 cases there is no radiation happening from that body. One body എന്ന് വിട്ട് ആ ബോഡി തന്നെ വരുന്ന കേസ് ഇവിടെ നടക്കുന്നില്ല അല്ലേ. So if there is a flat surface or a plain body or a flat surface, flat surface, F11 equal to F22 equal to 0. From എവിടെയാണ് സംഭവിക്കുന്നത്? For a concave body ഒക്കെയാണ് നടക്കുന്നത്, റൈറ്റ്? F11 or F22 equal to 0. ഈ സർക്കുലർ കേസ് നമുക്ക് പറയാൻ പറ്റില്ല. ഈ ബോഡിയിൽ ചിലപ്പം നടന്നു വരാം. ആ ബോഡിയിൽ ചെറിയ ഡിസ്റ്റോർഷൻ ഉണ്ടെങ്കിൽ, ബോഡി ഈ സിലിണ്ടർ ബോഡിയാണ്, ഇഫ് ദർ ഈസ് എനി ഡിസ്റ്റോർഷൻ ഓർ സംതിങ് ഹാപ്പനിങ് ഹിയർ, അവിടെ നടക്കാം. ഫ്രം ദാറ്റ് ബോഡി ടു ദാറ്റ് ബോഡി. ഓക്കെ, ഈ സർക്കുലർ ഷേപ്പിലെ ഫ്ലാറ്റ് ബോഡി, രണ്ട് സൈഡിൽ സർക്കുലർ ഷേപ്പിലെ ഫ്ലാറ്റ് ബോഡികളിൽ ഒരിക്കലും, ഫ്ലാറ്റ് ബോഡിയാണ്, സർക്കുലർ സർഫസ് എന്ന് പറയാൻ പറ്റില്ല, ദർ ഈസ് നോ സർക്കുലർ സർഫസിൽ ഒരിക്കലും സംഭവിക്കുന്നു പറയാൻ പറ്റില്ല. ഇൻ ദ കേസ് ഓഫ് ഫ്ലാറ്റ് സർഫസ്, ഫോർ എ ഫ്ലാറ്റ് സർഫസ് F11 equal to F22 equal to 0. അത് മാത്രം പഠിച്ചു വെച്ചാൽ മതി. ഫോർ എ ഫ്ലാറ്റ് സർഫസ് F11 F22 equal to 0. Okay, then we can do a problem. The radiation shape factor question. The radiation, please mark the two equations in a box. The radiation shape factor of the circular surface the radiation shape factor of a circular surface of a thin hollow cylinder of of 10 centimeter diameter, of 10 centimeter diameter, of a 10 centimeter diameter and 10 centimeter length, is 0.1716, 1716, 0.17. That is shape factor ആണ്. Radiation shape factor of a circular surface of a thin hollow cylinder of a 10 cm diameter and 10 cm length is 0.1716. What is the shape factor? What is the shape factor of the curved surface of the cylinder with respect to itself? So what is the question? There is a cylindrical body. It is a hollow cylinder. It is a hollow cylindrical body of diameter of a hollow cylinder of 10 cm diameter and 10 cm length. Okay, it is 0.1716. The radius shape factor of a circular surface of the hollow cylinder. What is the shape factor of a curved surface of a cylinder with respect to itself? ഒരു curved surface നിന്ന് അതിലേക്ക് തന്നെ പോകുന്ന റേഡിയേഷൻ ഷീൽഡ് കണ്ടുപിടിക്കേണ്ടത്. So it is, you can draw that particular figure as ഇപ്പോൾ നമ്മൾ പറഞ്ഞ എക്സാമ്പിൾ പോലെ തന്നെയാണ്. It is the figure. Okay, a hollow cylindrical surface, a hollow cylinder, the diameter 10 cm. That is, diameter is given as diameter equal to 10 cm. Therefore, R1, radius 1 equal to, you can take it as 3 body, that is first body, second body and third body. There are 3 surfaces here. Like, ഇത് 3 സർഫസ് ഉണ്ടാവും. ഒന്ന് ഇങ്ങേ ഭാഗത്ത് സർഫസ് ഉണ്ടാവും, ഒന്ന് അങ്ങേ ഭാഗത്ത്, മറ്റൊന്ന് കേർവ്ഡ് ആയിട്ടുള്ള റൗണ്ട് സർഫസ്. 3 surfaces there. So take on first 1, 2 and 3. 3 surfaces are there. Length is given as L. Length is given as 10 centimeter. So radius R1 equal to, R1 and R2 are same. R1 equal to R2 equal to 5 centimeter, right? R1 and R2 equal to 5 centimeter. Length is 10 centimeter. And is given as problem, radiation shape factor from a circular surface of a thin hollow cylinder. Circular cylinder shape factor from ഒരു എൻഡിൽ നിന്ന് മറ്റേ എൻഡിലേക്ക് shape factor for a hollow cylinder is, therefore F12 is given. F12 is given as 0.1716. Okay, f12 is given as 0.1716. f12 is our normal shape factor from a body from one surface to another surface. So here one surface to അതായത് ഇങ്ങേറ്റം അങ്ങേറ്റത്തെ കുത്തനെ വെച്ച് കഴിഞ്ഞാലും അങ്ങനെ from one surface to another surface. It is a hollow cylindrical part to another cylindrical part. That particular ending and close starting in 1, 2, 3 is there. So we want to find out what is the question. What is the shape factor of a curved surface of a cylinder with respect to itself? So curved surface is third body. So we want to find the shape factor for the curved surface to itself. So we want to find f33, right? f33 ആണ് കണ്ടുപിടിക്കുന്നത്. f33 to want to find out. So how can we calculate the value of f33 by analytical. So by summation rule, by summation rule, we know f11 plus f12 plus f13 equal to 0. Okay, f11 plus f12 plus f13 equal to 0. Again, we can write it as by summation rule. Also, we can write f33 plus f32 plus f31 equal to 0 or 1. It is 1 equal to 1. It is a body to that body plus that body to another body plus and that body to another. If there are 3 bodies there, equal to 1. If we can take second condition f22 plus f23 plus f21 equal to 1 by summation rule. Okay, then f31 equal to, I am writing some conditions here, f31 equal to f32. That is radius is same for both surfaces and length is 10 centimeter. When we are taking half or anything from ഈ ബോഡിയിൽ നിന്ന് ഇങ്ങോട്ടേക്കും ഈ രണ്ട് സർക്കിളിലേക്കും പോകുന്നത് that particular radiation shield value will be same. Or radius shield value അല്ല, radius shape factor value will be same because they are symmetrical. They are both are of same diameter. Okay, there is no any other factor affecting it. So third body from that particular radiation, third 31 equal to 32. f31 equal to f32. f31 equal to f32. Again, I am writing some condition. f11 equal to f22 equal to 0. f11 means that plane surface on that flat surface, particular circular surface. There is no radiation from that surface to itself. And again, that second surface is a particular circular surface. There is a flat surface. There is no radiation from that surface to itself. So f1 equal to f11 equal to 0, f22 equal to 0. What is the case of f33? f33 is not 0 because that is a curved surface and hollow cylinder ആണ്. So അതിന്റെ ഇൻസൈഡ് എടുത്ത് എന്താണ്ടാവുക, ഇതാണ് ഇൻസൈഡ്. അപ്പോൾ പുറത്തേക്കാണെങ്കിൽ there is no radiation inside. So അകത്തുനിന്ന് റേഡിയേഷൻ വരുന്നുണ്ടെങ്കിൽ അതെന്താണ്, മറ്റേ ബോഡിനെ തട്ടും. Okay, that body, it is inside, it is a what concave surface on inside. So it is a hollow cylinder. Therefore, there is a particular radiation with respect to 33. So f33 is you want to find out. So again, a condition is here f12 equal to f21. Right? f12 equal to f21. 1 to 2 equal to 2 to 1 because both are parallel and have same area. A1 equal to A2. A1 equal to A2 ആണ്. Same diameter. Same it is parallel with respect to 1 to 2. Therefore, f12 equal to f21. So write this condition as 1. f11 plus f12 equal to 2 as 1. And this second condition as 2. And third condition as 3. More condition നമുക്ക് വേണ്ട. f31 equal to f32. And 3 conditions. So how we can solve the particular problem to find out the value of f33. So here we know that f11 equal to 0. From 1 we know that f11 equal to 0. f11 equal to 0. Okay, And here, okay, a question advice. So here from 2, substitute 3 into, substitute 3 into, now let's see, substitute 3 into, substitute 3 into, so what is 3? F31 equal to F32, F31 equal to F32. Okay, therefore we can write the particular equation as 2 implies 2 equals to involve F33 plus F33 plus F31 plus F31 equal to 1, right? We are substituting F32 as F31. It is same, F31 equal to F32. Therefore, we are substituting F31 here. F4 in the case of F32. F32 equal to F31. So we are substituting the value of F32 to F31. So here we will get F33 plus 2F31. 2F31 equal to 1. Therefore, F33 equal to, we want to find F33 value, right? F33 equal to 1 minus 2F31. 1 minus 2F31. Therefore, the value of F33 equal to 1 minus 2F31. So, F31 value കണ്ടുപിടിച്ചാൽ മതി. To find the value of F33, this is a question. You want to find the value of F33. So, first we want to find here F31 ആണ് കണ്ടുപിടിക്കേണ്ടത്. So, F31 is the value to be find out. Okay. So, we know that F31 equal to A1 F13 equal to A3 F31. This is our first kind of, it was our first relation. We have studied in your earlier classes that A1 F12 equal to A2 F21. A1 F12 equal to A2 F21. Therefore, A1 F13 equal to A3 F31. A1 F13 equal to A3 F31. From here, F31 equal to, from the here we can write equation for F31 equal to, write down the F31. F31 equal to A1 by A3 into F13, right? A1 by A3, A1 by A3 into F13, right? A1 by A3 into F13. A1 by A3 into F13. So what is A1 by A3? A1, what is A1? A1 here. So circular surface area. Area, that round area, that is area of a particular circle.
Pi r square.
It's a pi r square. Pi r square. Pi r square divided by A3. What is the area? What is the area of a particular surface area? Circular curved surface area. 2 pi r
Pi dl.
pi dl. Okay. എന്താണ് സെയിം തന്നെ എന്താ വെച്ചാൽ 2 pi RL ആയാലും pi dl ആയാലും സെയിം തന്നെ. ദാറ്റ് ഈസ് 2 pi RL എന്ന് എഴുതിയാലും 2 into r ആണ് ഡയമീറ്റർ. 2 into r is diameter. Therefore pi dl. രണ്ടാണ് സെയിം തന്നെ. Pi dl. Pi dl. So we can pi dl എന്ന് ഞാൻ എഴുതുന്നില്ല. മുകളിൽ ആറിലൂടെ ഞാൻ 2 pi RL എന്ന് എഴുതുകയാണ്. കാരണം 6 ആറും കട്ടായി പോകാൻ വേണ്ടിയിട്ടാണ് എഴുതുന്നത് കേട്ടോ. 6 ആറും കട്ടായി പോകാൻ വേണ്ടിയിട്ട് 2 pi I am writing here 2 pi RL itself. 2 pi RL itself. And so pi and r is pi r. Then pi r bo. Pi and r. Remaining is A1 by A3. R divided by 12. R divided by 12. R divided by 12. R divided by 12 into F13. R divided by 12 into F13 ആണ് F31. F31 equal to R divided by 12 into F13. Therefore, what is R? R is 5 centimeter. 5. So calculate the value. Pi divided by 2 into 10. Pi divided by 2 into 10. എത്രയാണ്?
0.25.
0.25. Okay. F31 equal to 0.25 into F13. F31 equal to 0.25 into F13. That is our first equation. Okay. And then what is F13? F13 F13 from equation 1. From equation 1, F13 കിട്ടിക്കഴിഞ്ഞാൽ ഉത്തരമായി F31 direct to from 1 what is so equation 1 1 from 1 write down the equation 1 F11 plus F12 plus F13 equal to 1. That is our first equation. Here we already written that F11 equal to F22 equal to 0, right? F11 equal to F22 equal to 0. So F11 equal to 0. F11 equal to 0. Therefore we can cancel the F11. So we can, from this equation, you will get F13 equal to 1 minus F12. F13 equal to 1 minus F12. F12 is given in your problem. F12 value is given in your problem. So we can find directly the value of F21 is 1 minus 0.1716. 0.1716. What is the value? What is the value? 1 minus 0.1716.
0.8284.
0.8.
0.8284.
8284. Very good. 0.8284. It is the value of F13. So directly we will get the value of F31. So F31 as F31 equal to 0.25 into F13 equal to 0.25 into 0.8284 equal to
0.207.
0.2071. Okay. Therefore, F33 equal to equation we checked F33 1 minus 2 F31, right? F33 equal to 1 minus 2 F31. 1 minus 2 F31, therefore equal to 1 minus 2 into 0.2071.
5858.
Very good. 0.5858. That is our final equation, final value of F33. സോ ഇതുപോലെ പ്രോബ്ലമാണ് നിങ്ങൾക്ക് F1നും F2നും കേസിലൊക്കെ ചോദിക്കാൻ സാധ്യത. സോ ഓൺലി നമ്മൾ അറിയേണ്ട കുറച്ച് കാര്യങ്ങൾ ഏതാണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഈ പറഞ്ഞ കുറച്ച് തിയറീസ്, ദാറ്റ് ഈസ് സമ്മേഷൻ റൂൾ F11 പ്ലസ് F12 പ്ലസ് F13 equal to 1 and again F33 plus F32 plus F31 equal to 1 and again F22 plus F23 plus F21 equal to 1. അതൊക്കെ സമ്മേഷൻ റൂളാണ്. ആൻഡ് ആഫ്റ്റർ reciprocity theorem, that is A1 F12 equal to A2 F21. Reciprocity A1 F12 equal to A2 F21 or A3 F31 simply അതങ്ങോട്ടും ഇങ്ങോട്ടും. And thereafter if there is a flat surface ആണെങ്കിൽ that particular that is if first it is a first body F11 equal to 0, if it is second body F22 equal to 0, and if it is curved surface and given as hollow ആണെങ്കിൽ there is a particular heat transfer or particular radiation happening from that body itself. So F33 value never be equal to 0. If it is a particular problem of a solid cylinder, if it is a problem of a solid cylinder, that F33 value equal to 0. അതൊരു കോൺകേവ് സർഫസ് ആയി മാറും. Sphere, it is a sphere. From a particular sphere, there is no particular radiation happening from that body to that body itself. So F33 equal to 0. So these all theories. The question is, mark this question very important, and by referring this particular problem, we can do any problem in your textbook. ഈ question മോളിൽ വരുന്ന എല്ലാ പ്രോബ്ലവും ഒക്കെയാണ് മനസ്സിലാവും. That is our problem related with radiation shield. Sorry, radiation shield അല്ല, shaper, radiation shaper. So our next topic is radiation shield. So we can just start particular section and we can complete it tomorrow. Radiation shield. So what is a radiation shield? A shield is something, the name itself indicates that it is a particular shield that covers the radiation or which reduces the radiation. For what a particular example of particular radiation shield is a particular cover that particular welders are using. Welding ചെയ്യുമ്പോൾ നമ്മൾ മുന്നിൽ വെക്കുന്ന ഒരു cover is to reduce the effect of radiation effect. So in order to reduce that particular radiation from that particular body to our eyes, we are keeping a particular glass or particular face shield in front of us. So this is a perfect example for radiation shield. So that radiation shield is the particular particular shield that used to reduce the effect of radiation or reduce the value of emissivity value, reduce the emissivity radiation value by using the radiation shield. So there is an equation for radiation shield. If there is a problem asking like that, there is a two surface, there is a two body placed at something distance. First two body placed something distance of 10 centimeter, and there is a radiation shield placed middle of that particular plate. Problem is there in a textbook. So radiation shield is a particular topic. This is a very important topic. So you don't want to study the derivation of particular topic. You only want to know that what is the theory behind it and what is the equation of particular radiation shield. So as I said, radiation can be reduced. Radiation, the effect of radiation can be reduced by keeping a radiation shield between the two surfaces. Radiation between the two bodies can be reduced by keeping or placing a particular radiation shield between the two surfaces, and that surface have a particular emissivity value also. And if emissivity value of first one is epsilon 1, if there is epsilon 2 for second body, and there is a particular radiation value, emissivity value for particular radiation, ഇതിൽ ഇക്വേഷൻ ഒക്കെ നമ്മൾ ചെയ്യുന്ന സെയിം ഇക്വേഷൻ തന്നെയാണ്, മാറ്റങ്ങളൊന്നുമില്ല. If there is a body and I'm saying, so if there is no, we are taking a particular two parallel surfaces. If there is no radiation shield between them, we know that the equation for Q12 equal to 2 infinity plane. We are taking two infinity parallel plane, and if there is no radiation shield between them, we know that our equation is A into sigma T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. This is our equation for two parallel planes or two parallel surfaces 1 to 2. If there is a radiation shield, we can write the equation as, if there is a radiation shield, I'm drawing the particular figure. If there is a radiation shield between the two surfaces, it is the first surface, the second surface. If there is a radiation shield between the two surfaces, like third one, take it as a third one, take it as another body or another shield, and just we can write if there is emissivity value is first one for 1 and second body as emissivity 2, and we are treating that particular radiation shield as emissivity third. The radiation shield emissivity value will be given in a problem, and we can treat it as emissivity 3, and it has a temperature T3, and have a temperature T3. We can write equation as first 1 to 2, and we can write equation for 3 to 1, radiation from 1 to 2 and 1 to 3 and 3 to 2. That is 2, 1, 3. First one to radiation shield. From 1 to radiation shield, we can write as same equation. A sigma into T1 raised to 4 minus T3, T1 to T3 raised to 4 divided by 1 by epsilon 1 plus 1 by epsilon 3 minus 1. And Q3 to 2, second case, 3 to 2 as A into sigma T1 raised to 4 T2 raised to 4 minus T3 raised to 4, sorry, T3 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 3 plus 1 by epsilon 2 minus 1. Okay, there are two equations related to 4. So we can write equation Q1 to 2 net, Q1 to 2 net equation. That is Q1 to 2 net equation if there is a radiation shield between them. If there is no radiation shield between them, we know that our net equation is this one. Okay, if there is a radiation shield, we can write the particular equation as W net A into area into sigma T1 raised to 4 minus T2 raised to 4. That is 1 to 2 net. If there is radiation shield happening here, we can write 1 by epsilon 1, 1 by epsilon 1 plus 1 by epsilon 3 minus 1 plus 1 by epsilon 3 plus 1 by epsilon 2 minus 1. Okay, this is our net heat transfer equation if there is a radiant shield happening. If there is a radiant shield between them, we can write the equation like this, that is Q1 net, Q1 to 2 net equal to T1 to T2 ആണ് നടക്കുന്നത് അല്ലേ. അപ്പോൾ T1 to T2 divided by emissivity അടിയിൽ വരുന്ന വാല്യൂ എന്താണ്, ഇത് മുതൽ ഇതുവരെ പ്ലസ് ഇത് മുതൽ ഇതുവരെ, ഡിനോമിനേറ്റർ മാത്രം. 1 by epsilon 1 plus 1 by epsilon 3 minus 1 first case plus second case 1 by epsilon 3 plus 1 by epsilon 2 minus 1. Okay, this is the Q1 to net if there is a particular radiation shield is placed between them. Okay, we can conclude this particular equation and we can write a particular, we can study a particular problem with respect to radiation shield in our next class. Okay, and by 1 or 2 session we can wind up this fifth module also.